Happy Monday.
Yeah, happy Monday.
How you doing?
Yeah, pretty cool. Yeah, how about you?
Doing good, doing good. Just I think I finally recovered from jet lag, but I've had this like lingering cough for a long time, so I'm not sure if it's a bad cold or what, but it seems to be going away. So for the audience, if I sound voice is a bit deeper, that's probably why. But anyway, that's yeah, I had a good weekend. I went hiking, and climbing and a bunch of other stuff here. That's kind of what fall looks like in Utah. How about yourself? How was your weekend?
Yeah, it's pretty cool. I take my high school classmates to 70 Mile, and he flies from Vancouver and enjoy California.
That's awesome. Where'd you go
Yeah.
to high school?
In China, in Shenyang,
Okay.
a big city in northeast China.
Nice, nice. Well, it's good to have you on the show. For the audience out there too, Matt Housley's off. I think at a family reunion or something like that. So you just get me and Waymo today. Waymo is not to be confused with the self-driving car. He very well might be a self-driving car that I don't know about, but his name sounds the same. But Waymo, for people who don't know who you are, do you want to give a quick intro?
Uh, Thank you, Joe, for the great opportunity. Yeah, I'm the CEO and the co-founder of Postcrft, the first and only graphical engine on data lake structure and also on your tables. And I work at Telegraph and Google F1 team, the unified SQL query engine inside Google before.
What was the name of the unified SQL engine there? Sorry,
F1,
F1,
yeah,
like
but not
the race car.
Uh, they said it's not. They said it's based on some scientific term in hybrid breeding or something like that.
Oh, okay, whatever.
Yeah,
It's Google.
yeah,
So that's awesome. Well, we're here today to talk about Iceberg for SQL and NoSQL, and probably everything Iceberg related. I remember we were talking a couple months ago, actually, which is how this your appearance got started. We're in Mountain View
yeah, yeah.
at a party that Lynn Bender had put on. Shout out to Lynn Bender, by the way, great party. And I can't remember if we met before, but we were definitely chatting about a lot of Iceberg stuff, and then he gave Matt and I a ride back to our hotel. Then we were like, yeah, we should definitely do a show about this. So, um, first off, I suppose for the audience, for like the five people in the world who in the data world who don't know what Iceberg is, what is Iceberg? Let's just level set from first principles here.
Yeah, I think Iceberg is mm, maybe will be the standard of a table format. So you have files, and now with Iceberg you have tables.
Yeah. Well, I mean, to walk us through what was life like before stuff like Iceberg? What would you have to do?
Yeah, before that, since every data warehouse have their own design and they want to hold everything inside them, their software. So, for
Hmm.
example, if you are using Snowflake or Google BigQuery, you can only use the SQL query engine of them to access the data you put in the data warehouse. But you definitely don't want to do that, right? Since not only you want to use SQL to query your data, but of course any other things like APIs and NoSQL query engine, and sometimes you just want to read the file. So I think Iceberg open and is open and give you the possibility to manipulate and analyze your data as you want without paying the money to read every time for your data. Yeah.
Hmm. Yeah, that seems to be sort of the trend right now. I love your take on this. I think there's a ton of interest in the open table formats now, like Iceberg, for example. I think that's the main one people think about. There's also Hootie out there and others. But there seems to be a growing interest in adopting these open table formats because um, otherwise, as you point out, you have to pay the storage tax, right? And of course, if you're in a BigQuery or a Snowflake or even a Databricks, I mean, there's certain advantages because if you like being in one system, the storage is optimized for the query engine and it just works great. Um, but sometimes you don't want that, right? Sometimes you want flexibility, and so that's where these open table formats are getting attention. What are you seeing in terms of traction and companies using open table formats?
Based on my current talking with a lot of users who are interested in or already using data lake, I think Iceberg is the most popular one,
Hmm.
and then it's Delta Lake. But since Delta Lake have well supported by Databricks, so the Databricks user, of course, will use Delta Lake, but also some others who want to use Spark are migrating to Delta Lake. But definitely, Iceberg is the dominant in the last year, I think. Yeah.
Interesting. But I think like number wise, are you seeing like more and more companies adopting it? Because from where when I traveled around, it seems like there's a lot of interest, but I don't see like a ton of adoption yet. And maybe I could just be talking to the wrong people or seeing the wrong things. But what are you seeing in terms of like actual adoption with Iceberg, say?
Oh, this is really dependent on how large the data will be, since
Yeah,
it's directly related to the bill. And if a company have super big data, then they will consider about cutting the cost. So
yeah.
Iceberg is a very reasonable choice. And also, I have some observation, something like data observability and cybersecurity company, especially they like Iceberg very much because they cannot discard their data, but the data is generated every second, and also a single row of a value, the value of a single row in the data is not very valuable, but they need to do the analytics with aggregation and with all the data in the certain time interval. So definitely Iceberg is a very good choice because they can save a lot of money on the
Mm.
storage.
Yeah, that makes sense. It'd be probably more appropriate for companies with like large data sets because I could just picture like the migration to something like whatever open table format, say Iceberg. If you have small data, I don't even know that it would be worth the time personally because it's like that's engineering cost, and now I have one more thing I have to learn and one more thing I have to take care of, and it's like what's the actual benefit of that? Yeah, it makes a lot of sense. Like I think before the show we were talking about a situation where one um company had multiple different I guess you can call them cloud data warehouses or cloud data lakes, but I guess in the context of something like Iceberg, they're just query engines. So what are you seeing out there with that with respect to that? Because I think that's an interesting use case where you have um maybe you have a company that's been acquiring a lot of other companies. You have now many different databases. It's
Yeah, a friend of us is a senior director of a big company, and he's in charge of the data inferencing. And the big company acquire a lot of companies, so everyone use different data warehouse like Snowflake, BigQuery, Redshift, and now he is also promoting Databricks inside. And
interesting.
the problem will be how to integrate all this data together. And he mentioned to me that he had a plan, but sounds too crazy. So he wants to hear my suggestion, and my suggestion is that first migrate Snowflake and Redshift into Snowflake plus Iceberg and Redshift plus Iceberg, and then Databricks have Delta Lake. Then use unit catalog to manage the tables in Iceberg and Delta Lake at the same time. Then you can use whatever to talk with the Unity catalog and then
Hmm.
access all your data either in Iceberg or in Delta Lake. So this is a easy, kind of easy way, and also won't affect the current application of the different department. Like if you already still use Snowflake, and the interface won't
Hmm.
change. And he told me that oh, maybe he has the plan he had is exactly the same, so it sounds not crazy, but maybe it's crazy in the same way. Yeah.
That's interesting. Well, it seems like it could work, and it was interesting. I was talking to a friend of mine who was telling me about a company that had, I think, 70 database vendors. This was just last week. I was hearing about this. Not
Yeah.
70 databases, but like uh, vendors, and so I don't even know how many databases that is. But that was interesting because it was like I don't even know how you would integrate these things if that's even on the table, right? Because I think of the situation in the past is and I've had to deal with this, through the nature of some of the work we've done with M&A, stepping into companies with M&A, but it's like there's um, we talk about analytics, like OLAP environments, for example, integrating these data sets uh, up to something like, without the world of open table formats. That was like, okay, now we're gonna have to pick one vendor out of I don't know how many, say three or four, in this case three, and we have to pick that one, uh, or we basically tolerate the fact that like one team's going to use one system, the other one's going to use this one over here, and then whoever else is using this one over here, sure. That's been the reality of a lot of companies, and I could say from firsthand experience, it's insanely painful. Your data is going to get out of sync. I guarantee you, any analytics you have is at some point going to be done on data that's different. Just that's how it goes. And yeah, then there's just multiple issues, right? More data warehouses, more problems, as the old saying goes. So yeah, it's
Yeah.
interesting. Um, yeah, but it seems like we're entering a new world though, where maybe we can resolve some of these things. Like, do you think this becomes sort of a contest of the query engines then? So maybe Snowflake has a good query engine for certain use cases. Maybe Databricks has a good query engine and so forth. Like, what do you envision in this world where if data is neutral and it's in one place, what does that landscape look like?
Yeah. I think in my mind, I believe that Iceberg may be the something like the bus in computer architecture. Before we have a bus, each every two devices need to talk with each other. But after have the bus, all the devices talk with the bus, and then the complexity reduced from n squared to n. And
Yep.
yeah, and after I think in the future, first no one can charge just for table format, and the table format is totally free. And then it seems that the wall of vendors come to the catalog, and because at the beginning the file format is Parquet file won the battle, and is almost a standard.
Yep.
And after that, the competition happened in table format. So there are Iceberg, Delta Lake, and Hoodie. And it seems if there will be a conclusion on this layer, then the next step will be go up again and then into catalog. Since
Mm,
every big data player have their catalog, like Unit Catalog have sorry, Databricks have Unit Catalog, and Snowflake have Polaris Catalog, and
yeah.
Gmail have NICE, and also people are using Helm Store, and also uh, Amazon has Glue, so everybody
Yep.
can do similar things, and I think actually Starburst have an opportunity since they're doing similar things several years ago, but it seems they put this into enterprise features
Hmm.
rather than open source. So I think it's hard to get the position again since every other is open source the catalog related project. So
Well, and when you say catalog, let's be really clear what you mean by catalog. 'Cause I think in this case, you're talking about an API to talk to the open table format versus a data catalog in the traditional sense, where it's have a glossary of all my business terms and yada yada yada. Are these the same things in your mind, or are these different?
it's very similar, but more like a product. Since before that, every data warehouse already have their catalog, like how many tables and was the column type, the data type of each columns, and also the access control. And now every company want to open source it and make it independent. And then each catalog management software, something like
Mm,
that, can manage the different tables and also can treat it like a Postgres as external tables. So for the users, they don't need to set everything again and again. They only need to connect it with a catalog. And the catalog have the management of different tables from different data source and also have the access control in one single place and then
hmm
for all the other data source. And this save us a lot of time since when we do the query engine, we try to build something similar since because every data warehouse design some catalog management component by themselves. But now the life is much easier. We just connect with the famous open source ones, and then everything have been done. And another advantage is that no one want to set their access control on our side because they already did this again and again in different system. But now if uh, the catalog things has been adopted, and then everything already set up there. We just leverage and call the API, and
mm,
then we only need to focus on the performance and the design of our engine itself, rather than have a lot of enterprise feature to serve our customer.
right. Makes sense. Got a listener question here. Nityashri asks, what are some of the main barriers to adopting Iceberg at scale, particularly for the organizations that are heavy users of SQL and NoSQL databases?
Oh, I think this is a big advantage of Iceberg because it can be adopted very fast. First, if you have a bunch of Parquet file, you actually don't need to move them and do the data loading again and again. We help some of our customers just build on top of their existing Parquet file. And in our working section in 1 hour, and then they don't even know what's Iceberg before. And then in 1 hour, we set up Iceberg on their Parquet file and also connect with our query engine. And then they all their Parquet file modeled as a graph, and then can do the visualization and the query. This I think this is a big advantage. And then they also, because every big data vendor likes Iceberg, so they have their own integration, like how to migrate the data into Iceberg or do systems kind of stuff like a CDC.
Mm,
Yeah, so because it's almost a standard, so everybody is working hard to integrate their own system to Iceberg, and
yep.
that's a big reason it will be much easier to migrate different things into Iceberg.
Yeah, it seems like it. Before we started talking, you mentioned you actually had a really good soundbite, quote, insight, whatever you want to call it. But you said that basically you feel like Iceberg's going to become uh, basically the equivalent of the Postgres, but for the OLAP world. Explain what you mean by that.
Yeah, since Postgres is definitely super successful, since it's not controlled by any big company, but every big companies, every big company contributes a lot into Postgres, and they make a lot of money from Postgres. But there is no single vendor. Everybody can use it and benefit from Postgres, and it's almost the standard of OLTP. I think Iceberg may be the another Postgres, but
Do you,
for
do you think it's gonna be more of a Postgres or more of a MySQL, right? Because it's like Oracle controls MySQL. Um, I mean, Databricks dropped quite a lot of money on Iceberg. So I think that's sort of where I think the example falls apart. Is like you have like I agree that it's definitely a standard that everyone's adopting, but at the same time, I don't see the parallel with Postgres like line for line, because Postgres is, as you say, it's neutral.
Yeah.
But Databricks, I mean, they bought the tabular team, and I think the speculation in the industry, or the question mark, is like, is it truly going to be open, or is it not? Right?
Uh, in my idea, I think it can be neutral and totally open. Since this is an interesting story, since I think at the beginning of this year, uh, Snowflake and Databricks have an argument, Delta Lake and Iceberg, which is better. And definitely, Databricks said Databricks is better. And the Snowflake guys actually gave a lot of positive words of Iceberg and arguing with Databricks guys. But then suddenly things changed. This is because Confluent gave an offer first. Because
Mhm.
Confluent, they have a super successful product,
Yep.
Kafka, everyone knows that. But they want to keep the data in their environment rather than just let the data pass away. And then Snowflake and Databricks also gave the offer. But at that time, uh, I think the Iceberg community is much closer to Snowflake, and it's not totally controlled by any single company, but have the PMC include a lot of talent engineer from different company like Netflix, Tabular, of course, and also Netflix and Starburst
Mhm.
and Apple and Alibaba, and I see a lot. And also the community is super healthy, and
Yeah.
everybody make the reasonable decision rather than have some uh, purpose cannot disclose to any others. And the stand like a REST catalog API design. Actually, Tabular can keep it in as an enterprise feature, but they just open source it and define as the best practice of Iceberg. And also the interesting that Snowflake invited the PMC who was working at Apple to join Snowflake after the acquisition. They want to also have a vote in the committee. And it seems that, and also Ryan Blue is a super good guy. Everyone believe
Mhm.
that it won't happen that just because Tabular acquired by Databricks, and they will just something like MySQL have been acquired and be surpassed by some neutral and open standard. Yeah.
Yeah. Yeah. I guess we'll see. Right. I think that the concerns I hear out in the wild, around the world, is that, you don't drop close to $2 billion on something just for charity either. Right. So it's like,
Yeah.
you know what I mean? So there's definitely a reason
Yeah.
why a company would spend this much money, and I don't think it's just for the greater good of the community. There
Yeah.
has to be an economic interest in this.
Yeah.
And I think that's the concern, is like, okay, yeah, you say you're neutral now, but at what point are you not neutral?
Yeah.
So
Yeah,
it's,
definitely. But Databricks have to do it. Before that, they don't have any voice in Iceberg community
mhm,
because they have their own Delta Lake and it's a
yep,
are competitors. But now they have a big influence on Iceberg. But because it's already a good big community, I don't think they have uh, a chance to take a total control of Iceberg project.
yep, yeah. I guess yeah, that same down. I mean, yeah, again, it's time will tell on this one. I think that's the only thing. It's not like anybody except for the internal players actually know what's happening, and then I think we can only speculate. But like I
Yeah,
said, this is the biggest question mark. I mean, it's funny because no matter where I've been in the world, and it's Jesus' fault, it's been a lot of places so far. And even before that, the big question mark was just what does this mean? Kind of 1, 2 years, 3 years out. If we're going to get on the standard, this open standard, how open is it in, say, 3 years?
mm.
Is it still open, or do we have to fork it and cause a new iceberg? Like, break
Yeah,
apart the iceberg, as the old
yeah,
or make something called Titanic. Uh, it's kind of a morbid joke, but um, yeah, time will tell, right? I mean, this is just one of those things in the industry where I like to say we've been here before. So, but again, it's like you can only look at past examples, but it's not to say that that's indicative of what's going to happen in the future. So you just time will tell. But I think it does seem like there's enough, you know, parties across various factions where hopefully things are held in control. I think and I hope that's the case because for the greater good of the industry, this has to happen. Because I do feel like open table formats are the it's the key to the future. It's a key, I think, to unlocking a lot of potential with data that we just haven't had. I mean, up to now we've just had walled gardens, right? I think this is one of the ways things like data mesh works. For example, you
Yeah,
have to have a decentralized data plane in order for this to work.
yeah.
Um, or a way of sharing data, but it's just so I think this is one of the big steps to making it happen. So we'll find out. What are your thoughts on projects like Hoodie? What do you think happens to them?
It's also a good product, but I think of course, there are disadvantage and advantage and disadvantage comparing with different product. But it seems that if Databricks also contribute a lot to Iceberg and also like Snowflake, BigQuery, most of them endorse Iceberg in the last 12 months. So I think this is a big reason Iceberg growth is much faster than the others.
Yeah, I think it'll be interesting. Part of me wonders, like, if something like Hoodie doesn't, um, if it sees more interest because it is the third party option. Third party being the first parties being all the proprietary storage formats, and you have Iceberg, then you have Hoodie. And I don't even know who number three would be. I don't even know, but you kind of see this right now. Like if you look at like file formats, right? It's not like Oric or Avro went away. And people still use them, but it's just different strokes for different folks, I guess. So, but it does provide a different option in the marketplace. I think that's also needed just in case something does happen where say that Iceberg isn't as benevolent as we thought. Then it's like then you have another option out there. But as you say, it's about maintenance too, right? And how long can you maintain a project and keep it at parity, especially when you have a lot of big vendors with a lot of great engineers focusing a lot of time on Iceberg, right? That's the reality of it. There's a lot of attention, and a lot of attention usually means like a lot of great pull requests and a lot of great releases. So yeah.
And definitely there will be opportunity for Hoodie as well, especially because after Snowflake, BigQuery, and Redshift invest in Iceberg. Currently, they may have the similar concern, like what if it's in control by Databricks? So they definitely want to have alternatives, alternatives, so to make sure they are safe. But because based on their existing investment in Iceberg, uh, current user will prefer to migrate from the total data warehouse into like data warehouse and Iceberg. It's because it's already well supported, and the data warehouse guys already spend a lot of time to do the integration. But it's not very easy since like Snowflake, they already spent I think 2 or 3 years to support Iceberg. It's just not just connect and query, since their own storage is very different than Iceberg.
I mean, it
So
was custom made from the beginning, from the ground up. I mean, their micro partition architecture was like, um, for obvious reasons, it's closed source because you can't see under the hood. But I know that they spent a lot of time building it. Like that was literally the foundation, and it works wonderfully. Works
yeah,
wonderfully.
yeah, definitely, yeah,
Yeah. So then to re-architect the Snowflake query engine to work with a different format, yeah, it's not easy. I mean,
yeah.
no, it's not like you're setting up like a JDBC driver to go connect to like I think it's a bit more work than that. It's so One thing I think is an interesting thing I'd like your take on is like, um, what are some of the possibilities you can get with these open table formats like Iceberg that you can't get or we couldn't really get before using proprietary source? I'm not talking about cost savings. I'm talking just like from an engineering perspective. Like, what are some of the things I can do as a data engineer or data scientist that I couldn't do before?
Yeah. Uh, Actually, my experience is can explain this point a lot since I was at a graph database company after I got my PhD and worked there, but it's very hard to be adopted since
Mm,
then everybody have a terabytes of data, no one want to move it. And after I joined Google, I realized that oh, we can query the data as it is, and the performance can be still good. And then I'm looking for something if I can build a graph data warehouse or something like that. But it's hard because you don't know where your your customers' data currently in. Like
mm,
if they're already in Postgres or already in Snowflake, you lack of information to do the optimization. Like you don't know table stats, and you uh, then you cannot do cost-based optimization. And also you have to go through the API provided by Snowflake and BigQuery. It's usually just SQL. But now we see some storage API, we can read and write it directly. But then I read a blog, XNZ invested in the Iceberg team, and the Iceberg team left Netflix to create the company called Tabular.
yeah,
Then we have a super simple demo to the tabular team and show how a graph query can run on top of Iceberg and have a better performance than most graph database.
interesting.
This is also a surprise of, for the Iceberg team because it's optimized for SQL. But when you do
The formats, the storage formats optimized for SQL, or your graphs optimized for SQL.
the Iceberg table format
Yeah.
actually are optimized for SQL, but at the same time, it can benefit all kinds of data analytic workload. And then uh, we have a long term, several years collaboration, and not only on engineer but also for marketing. And it's a gave a lot of possibility. Like we also see some other SQL non-SQL query engine like Daft, and also of course Spark can also directly on top of Iceberg.
Hmm.
So it's just which means before that NoSQL including two part. One is that the API is NoSQL, and also the storage is designed for this NoSQL. But in the last 10 years, a lot of things have happened and technology changed a lot. Like S3 is faster and faster. Especially last year, they claim they are 10 times faster uh, than before. And we can see that NoSQL is more valuable on the API side, which means the user can think in NoSQL mode. But for the machine side, they don't need to design specifically for that. They can just leverage the table format like Iceberg, and the engine will handle uh, some the fill the gap between NoSQL and table format. And the user can leverage the benefits like they can think in NoSQL mode. Sometimes the problem is not uh, it's not hard to express in SQL, but now they can just think in uh, some other mode like Graph and also Spark, and then the underlying side, the engine can handle for them, and also make it fast. Not like people think if it's not a storage design for the uh, this data model, then the performance will be bad. But after we do the experiment and also think about the theory, we believe that this can be handled by the engine itself.
What is it about open table formats that work better with your graph situation?
Uh, since especially for the analytic workload. You can think that every graph tool in the market is a graph database, so it's a row-based system. But if user only want to do graph analytic rather than transactional inserts, nodes, and edges, the column base is definitely a better choice because they only need to access the necessary attribute in
Right.
the query. Otherwise, like if you have some, like you have 100 attributes, which is pretty common in the current area, and also some attributes are super long, like home address or even profile picture, something like that. You don't have any reason to load them into the memory when you do data analytic. And
Right.
then we can see that the column base can leverage the not only SQL query engine, but also a lot of other engine as well.
Is that because in row-based type queries, you have to scan through each and every row, and you're getting each and every column as a result, and it's most of it's redundant? Yeah, so that makes
And
sense.
and also we can use some technology like vectorized evaluation. So
Yeah,
one CPU instruction can handle a vector plus vector, something like that,
right.
rather than a for loop, because on the same column, all the data type are exactly the same. Then it can be faster, maybe 30 times or even more. Yeah.
Mhm. Makes a lot of sense. That's super cool. And kind of back to your point about the SQL and NoSQL, can we elaborate on that a bit too? So what I heard you say was basically uh, an open table format provides the same underlying storage, OLAP storage querying, or the ability to query OLAP storage for both SQL and NoSQL engines. Can you maybe elaborate a bit further on sort of the technical considerations of that? Like what happens under the hood in this sort of a situation?
There are on both application layer and also the underlying technology. For the application layer, the biggest benefit is that you can have a query script include different things. Like first statement is a SQL in SQL. The second statement is in graph, for example. And the third one, maybe you just leverage the results to use Spark. Then you can uh, your output can be our input, and our output can be others' input. And then we don't need to handle how it's distributed. We can just write back to Iceberg, and everybody can use it as well. And also, there are a lot of more features integrated with Iceberg, like streaming, and we can see Kafka, Red Panda, Pauser, and Racing Wave, and a lot of vendor integrate with Iceberg. And also like batch loading, like Observer, are super good at loading, but they don't need to care about the data format. They don't need to design by themselves. And also like maybe everyone believe that Iceberg is hard for real-time analytics, but this also show the possibility, like
Hmm.
ourselves do some cache and the index layer to make the analytic real time. And also there are company who uh, team from single store, they are building a company called Mooncake, and they want to open source
Oh,
it,
cool.
have a two-layer cache on top of Iceberg, then make the Iceberg performance in real time as well. And we can also see that a lot of vendors like spatial features, add the spatial features and add the time series feature into Iceberg. And then they also don't need to do everything by themselves. They can just working on what they are super good at, and then all the others leverage Iceberg to do it.
Yeah, makes a lot of sense. Um, so with these sort of polyglot use cases, right? Because we're talking like streaming, we're talking about graph analytics with SQL, with data frames, and so forth. Um, how do you think about data modeling, like modeling the underlying data set in such a situation?
Yeah. When I was at Google F1 team, we have some interesting thing like we define everything as a table and then use SQL to query it. Like if you have a table in Spanner is a transactional database, and then we can use the analytic engine to query the transactional database.
Hmm.
And also we can define logs as a table because logs have a certain format inside Google. Everyone's log follows the same format. And then we define each field as a column. And then we can also define JSON file and a proto file, like because they have schema. And then we can have select A point B point C to have a different uh, we can have get different field. And then it's kind of logically flattened JSON file or proto into a table.
Yeah. But I guess
Yeah.
how do you decide what goes into a table? Like you say the word table, but like what in your mind is a table?
Yeah.
From a conceptual sense, right? Like what stays in this table, what doesn't get into the table?
Uh, s- in my idea, everything can be a table since it just maybe waste some storage, but logically you can also treat it as a table. Like for example, if you have one JSON file and have a JSON array, and each uh, JSON object have the same schema, and then you can just make every attribute as an attribute of the JSON object, make all of them on the same level, and then it's
Yeah, but that's what I'm asking. It's kind of like when you think about data models in the traditional sense, right? It's like you have if we're talking about normalized data, for example, like you have a customer table, a product table, yada yada yada, pretty simple. Uh, but then when we're talking about this, I'm imagining like what's the grain of each record, for example, like what fidelity are we talking about, and what is this and what does each row mean exactly? Like how many concepts are we trying to cover in a single table at a certain grain of each row?
yeah, and I think I don't see any very common standard about that. But for our
Mhm.
side, we're just trying to have some a lot of workaround to make everything like Elasticsearch, and we also
Yeah.
try to define them as a table because our data modeling design that if your table are normalized, and then you
Yep.
can define each table whether it's a type of nodes or it's a type of address. And if you have two columns from and to, from and then you can define the and as a type of address. And then finally you will have a graph. But the interesting part is that you
Mm.
don't have a deterministic result when you modeling your tables as a graph. So you can have different graph based on same set of tables.
Right.
And we have an automatic tool, but it cannot you always give you the best answer. Sometimes it's even it's correct, and it's still not good. So I don't see any common standard on that. But from the uh, how we, based on how we it show a lot of possibility.
Yeah.
Yeah.
Yeah, I think it's one of the big cruxes of that because I think because as these as something like Iceberg, I think goes into more say traditional types of companies that are using say data warehouses. They're not operating at Google scale, right? They're not doing F1 and Spanner and need to have like one table where it needs to be highly performant. We can't even join anything together because it's going to screw up the speed, right? It just needs to have like everything in it.
Yeah.
But most companies don't think like that, right? Most
Mm.
companies, when you're talking about analytics, no lap workloads, it's about probably a couple, well, three ideas really. It's either you're going to be doing a dimensional model in the form of like Kimball, or you're going to be doing data vault, or you're going to be doing one big table. Those are the top three analytical modeling techniques. I could say that one big table is almost the absence of modeling in a sense, where you're just like throwing everything to a table because you're like, screw it, I don't know all of
Yeah.
it.
Yeah.
So I think that's kind of why I was asking the question is it's translating these concepts into these open table formats. Whereas you say there's a lot of flexibility, just as there is right now, actually, in the proprietary formats. I mean, when you're talking about, say, Databricks, I mean, you can definitely go SQL. You can go data frame. You could put what is it, SparkX or something on it, which is a graph tool on it. I think
Oh,
from Sparks.
there is
Is
a
it
tool called GraphX, I think.
GraphX? That's what it is. Yeah, yeah, GraphX, or whatever, right? But it's like, but I think the big question mark is going to be like, okay, so like, do I model my data the same as I did before? Do I model my data differently? Like, what's the catch? So
Yeah. And for some of user, we just trying to attach the schema to the query. And one of customer gave us feedback. Thanks to David Hughes, he gave a name. You called schema on read rather
yeah,
than schema on write. So each schema can attach to each query. So
yep,
for so which means uh, uh, your schema and another one's schema may be not the same, but it's still query on the same copy of data.
yep,
Yeah.
yeah, yeah. It's yeah. I think we've seen that we've been through a few. I think that there's pros and there's cons to that approach for sure. I think you got to know what you're doing if you're going to do schema and read. I think because it's a different beast than when you have kind of a very fixed, predefined schema where I think everyone knows about it. And yeah, um, but that's kind of the thing too. It's one reason I'm writing a book on data modeling. I think is at least to make people aware that when you're working with data, I don't really care if you do schema on write or schema on read. To me personally, it doesn't affect my life one way or the other. But to bring you happiness and joy in the world, please understand the various ways of working with data,
Yeah.
understanding also the way it's stored, right? And the query engine you're using and so forth. Like, how does this work? You kind of need to know both. And I think all too often we stick rigidly to like one or another. Like it's all about performance. Like the data model doesn't seem to matter at all. It's just throw everything in, even if the grain makes absolutely no sense whatsoever. But on the other hand, it's like people who rigidly model and almost at the expensive, the convenience of some of the technologies they're using, right? So it's you got to know both. To me, it's like a issue of like knowledge and technology, and being able to join these two together make you really powerful. But if you're doing schema on read and you don't understand like the underlying data that you're working with, for example, or um, what you're doing, I've seen that go to some pretty crazy places. So, but
Yeah. Since uh, in my mind, it's just a guessing. Since maybe in the future, the logical data model and the physical data model can be totally separated. So for the data scientists and data analytics, they only need to care about the logical data model. And some engine will handle the underlying layer. And they don't need to care about how the data physically stored. But this is just an ideal case in my mind. I'm not sure.
yeah,
Uh,
yeah, I think it's a bit to get there. I want to see that world too. I mean, I was actually thinking about this the other day and like giving a was part of the talk I was giving when I was in Australia and New Zealand was really just this notion of even a way to like unify the conceptual, logical, and physical models all in one shot. So like um there's no discrepancy between these. I actually may have a way to do that, but um I'll write about it and then people can pick it apart. I don't really want to talk about it on the show, but it's one of these things where I feel like right now it's yeah, I don't know, but yeah, I think you're absolutely right. If there's a way where you could just query the data, it doesn't need to don't need, really need to care. And there's some projects like that I think that are trying to attempt this. Like IBIS is one of them, where um, you can like just write a query once, and then it can farm it out to whatever query engine you want and do your thing. But we'll see. So it's still early days. So yeah, That's cool. What else are you excited about?
I think I think the good thing is that this area is super competitive. So the build size will be smaller and smaller because everybody want to make certain components free. And
Oh,
then,
yep.
yeah, this is very different from 10 years ago. Yeah, since 10 years ago, everybody want to lock their customer in the vendor supported closed source software. But now you cannot have charge very high price for your customer. You need to keep your product the best because everybody is trying to promoting the concept which is called no vendor lock-in. Yeah.
So walk me through this because 10 years ago and before, right? I mean, but the notion was data gravity,
Mm.
right? Like we have your data, therefore we kind of own you. Moving from this is going to be very expensive. I'm talking from the perspective of a vendor. When I talk to vendors, inevitably this data gravity comes up in the conversations with their salespeople, right? Like if
Yeah.
we can just get the data, we got the customer. But what
Yeah.
you're saying is this is no longer the case. I do agree with you, by the way. What happens? How do you compete? How do vendors compete now?
I think they need to keep their technology most advanced and at least most match their uh, customers' requirement.
Right.
And uh, if it's no longer a good one, and user have the flexibility to do a replacement.
Yeah. It's going to be an interesting world that we're entering into if this is the reality that we're going into where data gravity isn't as much of a thing, right? Um, you can actually see this happening in the machine learning world too. Like the cost of training a model is so much higher than your egress cost for your data that
Yeah.
it's like if it costs you say 100 maybe a few $100s per gigabyte of trained LLM, for example, and it'll cost me like what 5-10 cents per gigabyte to egress it out. Like of course I'm going to train like where I find the best engine,
Yeah.
right? So I think that sort of yeah, that was a conversation I was having with Andrew Ng, where he was kind of like, yeah, he's kind of questioning the whole notion of data gravity, like what doesn't seem to matter in machine learning anymore because it's
Mm.
you're talking orders of magnitude in cost difference between training and egress. Like who cares? Uh, and I always had this thought that like egress fees were going to go the way of I don't know if you're old enough to remember cell phone minutes on your phone, where you'd buy like I don't know X number of minutes per month, and you'd use them on your phone. But now it's all unlimited; it doesn't even matter. And I felt like egress is the same way. Obviously, there's a lot of telco cost you got to pay under the hood with the egress, but yeah, and it feels like I think you're right. The data gravity is an interesting one where that goes away. But as a vendor, then it makes me really nervous because now it's like um, I have to I have to be that much more awesome every day.
Yeah.
Like that's hard. It's hard because I don't think it's emotion they're used to, right? Because I think precisely because you live in a world where you can take data gravity for granted, it's like you could move at a pace where it's just like we just need to go tit for tat with our competitors, but because it's really hard for or your customers to switch,
Yeah.
um, it's it goes a bit slower.
Yeah.
Now, if data is in a neutral spot, all we have to compete on is just mono who has a better query engine. Like I don't know this hour,
Yeah. Exactly.
so
Yeah.
is it one of the things where we just end up like somebody comes along with a punch pass where I can like get access to all the query engines for a discounted price, and I just um, I can use Snowflake for one, a couple punches here, Databricks over here. Maybe an interesting subscription model actually. Just made that up, uh, but it's
Yeah.
kind of a stupid idea, but it could work. Yeah, I don't know. It's fascinating. Um, got a comment here. This is Lakshmi. She says, I don't think this NoSQL concept based data processing would be able to fit in 100% with traditional database concepts of data modeling. The flexibility of schema design kind of disturbs initially designed Kimball, I think is what she means approach. I would love to hear more. Thanks for the session. It's knowledgeable. I don't know. What are your thoughts on this comment?
Yeah, I think at the beginning, the NoSQL claim, the NoSQL word claim there, the biggest benefit is more flexible. But then the problem is that SQL is definitely dominant, and let the users and the customer to enjoy the flexibility is hard, since no one want to have another database. Everyone want to have one database which is the ground truth, and maybe you have a data warehouse and then CDC between them, but just for the flexibility of NoSQL and then keep another copy of data, sometimes it's not worth it. So
Yeah.
yeah,
I mean, it's interesting. Michael Stonebreaker, he had he's one of the OGs of the relational database movement. And I think he spearheaded Ingress, which later became Postcrft. So he had a paper that came out in June. What goes around comes around and around. I think it was a sequel to his other paper that he wrote, which was what goes around. But it was basically a survey of all of the different types of NoSQL databases and the fact that they all inevitably become SQL databases or SQL language with a relational database at the end of the day, an RDBMS, not a relational data model, but the relational
yeah,
databases is whole observation. Like at some point, no matter what, SQL seems to become a first class citizen and they start adopting RDBMS features. But I think as a counterexample to what Lakshmi is saying, though, the fact that if you were to take a true Kimball approach, right, like nested data you wouldn't have nested data in your fields because that would simply be you would flatten those out to be cells. But like, why is it that um, some variation of JSON, as a first class citizen, not only in things like, any data warehouse now that you think of. I mean, it's a column type, but also in Postgres, right? So, and in Postgres, I think just released a JSON table, I think it was. So you could actually have a whole table that is just a document table, basically.
yeah,
MySQL, I think, had that for a while too. But so it is interesting because I think, what you are seeing is we're doing like kind of Kimball light, where it's like, sure, if you want to do it that way, but I think for a lot of reasons too, as you point out, like when you're dealing with data frames, like I don't need to be encumbered by some star schema. I can just query whatever the hell I want, and like, or a
yeah,
graph. Like I don't think Kimball has anything to do with graphs. So I think you were living in this is part of the notion of the mixed model arts talk I've been giving, where it's like you got to learn the different techniques of working with data. It's not just dealing with star schemas anymore. It's like you got graphs, right? That are, I think, increasingly, I mean, they've been around forever, but increasingly they're coming into vogue for a lot of reasons. Like people are excited about graphs. So tons of awesome stuff there. And then obviously data frames have been around. Actually, data frames, if you look at the history, data frames came out at the same time the data warehouse did. It was
yeah,
1990. It was in that's came out.
yeah.
So it's sort of a tale of two worlds that are now converging. So
Word
those,
back, yeah,
yeah, it's pretty funny. But yeah, I think not a lot of people know that, but data frames did come out back in, I think, 1990, when same year that Bill publishes a book on data warehousing. So anyway, it's interesting. I mean, I think what's old is new again, and so, but
yeah,
and I think it's a good point with the what you're saying with Iceberg for SQL and NoSQL. These just end up same as ever was, right? So
yeah,
it's awesome. Well, cool, man. Good conversation. It's great talking to you. And like I said, I really like our conversation back when we were chugging beers in the beer garden in what was that place? The Olympia, I think it was
yeah, yeah, yeah,
yeah, Olympia Beer Garden. If you ever get a chance, audience, to go there, do it. It's a great spot. It's kind of I think a Mountain View staple, so super fun. But Waymo, great to talk to you, man. For people who want to learn more about you and what you're working on, how can they find you?
You can send me message on LinkedIn, yeah, and I log in every day. And, yeah,
Log in every day.
uh,
Hopefully, you log in and check messages and stuff. But yeah, it's yeah, you're fun to talk to. So thanks for being on the show. Next week, I think Matt's back next week. I'm not sure. But we'll have Paco Nathan on the show. So if you know Paco, he is, I think, one of the most just one of the most awesome people in the entire data industry and the AI industry. The guy's been doing AI, I think, for like 40 plus years, something like that. So yeah, he's an OG. So where the conversation goes, I don't know. He's actually a graph expert as well. If you guys have not met, I would say Weimo, you and Paco should meet. And he's just utterly fascinating. So, but yeah, so that's a guest on there, and then I got got another guest on there. Then Matt and I have a special announcement coming up very soon, so stay tuned for that. But anyway, thanks to everybody. Great questions, discussion points. Thanks, Weimo, for the awesome chat as always, and we'll see you next week. Take care.
Yeah. Thank you so much, everyone.
Thank you.